There we go. There we go. Awesome. All right. So what do we think about this? How many squares would be in figure number 75? Super close. 76. What makes us say 76? How do we know? All right. Y'all, it's my turn to talk. I was going to say, and there's like chair. So I'm with us on 76, but there was way too much not conversation about why 76 for me to let that fly. Why 76? Say a little louder, I'm old. Yeah. So, well, figure 1 here has 1 square and then an additional 1. Figure 2 has 2 squares and plus 1. Whoop. And figure 3 we're seeing with 3 squares plus a bonus 1. So sometimes it's just that we take whatever that figure number is that we're looking at and we add 1 here. So if we wanted to write this as an equation or an expression, I could take whatever our figure number we're looking for and add 1 to get exactly where we want to be. We noticed that this is just one more thing than what it was called. These kinds of pattern activities we will have pop up, especially for during attendance time, repeatedly. And that is partly because when we get into some of our later chapters, we will have these patterns that show up with more than just, one more than the number. And so the pattern recognition part of it is going to be something we need to practice because there is a pattern on the spring final that's over like everything that is, we have to be able to see what's happening and what's changing and what's staying the same to do so. It shouldn't be like a really hard problem, but it was one of those ones that was kind of surprisingly low last year. Not saying for any particular person or any individual, I mean in the state, because I'm in a group chat with basically all the prime teachers in the state. And the question with the pattern was one of the lower questions, and it really shouldn't be. So we will have patterns like this pop up regularly and repeatedly because pattern recognition is something that, not saying it's something y'all struggle with, but something that was struggled with last year. And so to kind of prevent that from being a sticking point for us, we're going to practice these patterns a bunch. It's not super long. It'll be something like this. We'll talk them through. We'll try and figure out what we're noticing, what we're seeing, what we're not seeing, that kind of jazz. But just kind of building that up because sometimes seeing the patterns is a little tricksy, especially when we get into some of the more complicated ones. And we're just going to practice them, bunches and bunches. Okay? So we are going to be working in your workbooks today. I know, sure. We're going to be on page 54. Because remember, like I said, the first chapter is actually our third chapter because I printed them out of order. So we're going to be on page 54. Looking at some stuff. And what we're trying to do today is we are going to be stretching our mental math muscles. We're going to be doing some playing with known facts, and we're going to do some estimating kind of activities. So on this page 54, at the very, very top, we give you some information. We tell you that 13 times 17 is 221. Straight up, we tell you that. That's this guy right here. I've got it on my page. You've got it on your page. 13 times 17 is 221. So what we want to do is we're going to use that information so that I don't have to take this page, type everything in the calculator, and go from there. We're going to do this without calculators. We don't need them. So everything on this page is based off of that fact. So if we look at part A, which is this first one here, 13 times 1.7. What do we notice about this? It's got a decimal point in it, but a lot of the information's the same. How could I take, or how do we get from 17 to 1.7? What is the difference between 17 and 1.7? What is the relationship between 17 and 1.7? What's up? 17 is a whole number. Yes, 100% with you. Totally good. Love it. What else? How could I get from 17, which is something we know stuff about, to 1.7? How does 17 get changed into 1.7? Yeah, we move the decimal up one. How do we do that in math? How do I move the decimal to the left one? I told you, I'm going to ask an obnoxious number of questions in this class. You will get so sick of it. How do we move a decimal place over one? Think about what each place is called. How does it change in between? Ooh, say it louder. We're moving it with 10. So if I'm making this smaller as in I'm moving it left, we are actually dividing by 10. Or if it helps, and if you think about it this way, you could times it by 1/10 if you're a fraction person. That means the same thing. I know some people don't like that. I'm just going to change the color on it real quick. You could think of it as times 1/10. That does the same thing. So if we know that 17 divided by 10 is 1.7, then I could think about 13 times 1.7 as 13 times what we noticed up there. 1.7 is the same thing as 17 divided by 10. Well, we know something about 17 and 13, right? I know 13 times 17. 13 times 17 was what? 221. That means the same thing. They are equivalent. They mean the same thing. I switched my 1.7 to be the 17 divided by 10 because they're equivalent. They mean the same thing. 13 times 17 is 221. They're equivalent. So all we have left is 221 divided by 10. What is 221 divided by 10? Remember, what does 2 dividing by 10 do? Yeah, it's going to take our 221 and move our decimal place left one because we divided by 10. So dividing by 10 moves our decimal place left one. So we can take 13 times 1.7. We got 22.1. We didn't need a calculator. You guys had that exactly right. 100% exactly right. We don't need no calculators. We're super awesome like that. Same vibe on this next one. Let's look at B here. Now we have 130 times 17. What do we notice on that one? We've got an extra 0. So now, instead of us being dividing by 10, what happened to this one? It multiplied by 10. 130 is the same as 13 times 10. That means the same thing, right? They are equivalent. So this is the same thing as saying 13 times 10 times 17. Well, 13 times 17 we know a bit of. So 13 times 17 times 10 is the same thing as 13 times 10 times 17. Doesn't matter what order we multiply in. What are we going to get? What is 13 times 17 times 10? We're going to have our 221, but we have our extra 10, so that means we're getting an extra 0. 2,210. Okay, so see if we can figure out where things are getting more pieces, where they're getting less pieces, where we're multiplying by 10, we're dividing by 10. Everything is doable with mental math. You do not need a calculator for this. I want you to try and finish this page out. We're going to talk through all of them, but I want you to give it a try. So take just a couple minutes and look at the next few. We did A and B. So we're going to look at C, D, E, F, and G. They're just not up here, so take a look at those and see what you can come up with. And we'll talk them through here in just a minute, but I want you guys to try on your own. Not with calculators, not on your phone. See what you can come up with. See if you can figure them out using the same kind of things we just did. I'm just writing them up just so we can look at them. Cool. All right. Come on. Say if you're on your phone, I might hand you the iPad and have you do one, because I'm gonna assume you're done. I am not afraid of bribery and or shame. Say I can put it back on the other page if you need. I'll put it back here if you want. I love when there's discussion. I love when y'all debate each other about stuff. I really do. I am just dropping things everywhere. Ow, that's gonna bruise. That hurt. But I'd rather my foot bruise than my phone break. So. No, it's one of, I dropped my phone and I like tossed my foot underneath it so it lands on your foot instead of just like on the floor. I've definitely never done that before and shattered my phone. Yeah, definitely never. No. I'm like, I can heal bruises. I don't want to buy another dang phone.
Did that big pencil actually work?
Yep.
Do you get you when they don't have a pencil?
Huh?
Do you get when they don't have a pencil?
I was gonna say, when I ran out of pencils last year, that was the threat. I was gonna say, if my pencils keep disappearing, this will be the only one I have.
And it works.
It works.
And
Eraser
it
works too. I don't know how we'd sharpen it though. I think I'd have to whittle it. I also think this is just hot glued in here. But yes, it does work. I feel like a small child. I feel like I should use these in like productions of Charlie Brown.
You should.
Because I definitely didn't have one about that size when I was in Charlie Brown.
That could definitely be a crop for theater.
Definitely. But it works too, so it needs to be in here. But yeah, no, I definitely, when I played Lucy, did not have a pencil this size when I was writing it. Definitely Lucy Van Peltz. All right. Let's start by taking a look at these. What did we get for part C? Yeah, 22100, 22,100. We should have two extra zeros at the end. Like, that one's not usually one we struggle with. That one's usually okay. It's very similar to part B that we did together. What about for part D, option D? 2.21. The most common mistake I get on that one is 0.221. Just saying. So if you got that, that is super duper common. Just be really careful on how many times things get moved decimal place wise. Okay? E, F, and G, they give you a little bit of a wrench. They start going the other direction. We've got 2,210 divided by 13. 170. Good. What about for F? What do we think about that one? The 22,100 divided by 17. 1,300. It's actually halfway working backwards from this one, because we had the 22,100 and we're dividing out the 17. It'd leave us our 13 and the 2 extra zeros. So it's very much similar to this one. This one's probably the hardest one on this page, G, because we're dividing by a decimal and it's gross. What do we think on G? I think. I see 100% why we got there. Not quite though. Okay, so let's walk through it. I'm gonna do the thing that everyone gets most upset at me for. I'm gonna write this as a fraction. Ew. What if we did 221 divided by 1.3, and we wrote it like this, and then I go, ew, I really don't like having decimals in my denominator. Gross. As long as I do the same thing to both the top and the bottom of a fraction, I can do whatever the heck I gosh darn please. So if I want to make this 1.3 be a 13, what would it need to multiply by? How do I get from 1.3 to 13? Move the decimal to the right one. How do we do that math-wise? Times 10. If I take this guy times 10, I'm still at exactly the same fraction. As long as I do the same thing, top and bottom, we can totally do that. That is one way to look at this. That would give us 2210 when we multiply that by 10, divided by 13. Can we figure out what it's going to be now? 170. So that is one way to think about it. There are lots of ways to think about this one. You can think about it like a fraction if you are super duper anti-fraction, which I know sometimes we are, and that's valid. I get it. Another option for it is to think about our 221, and when we divide it by our 13 divided by 10. We can take our 221 divided by 13 and get our 17. But then we got to remember that this still is being divided by 10. So it's actually times a 1/10. or divided by 1/10. Sorry. This is something that has now canceled out with the 17 here. So we have our 1/10 and our 221 divided by 1/10. We're left with the 117. If we think about fractions, dividing by fractions is the most gross thing ever. But we had a little phrase for remembering what to do with fractions with division. Way back in the day. We would keep, because that one was fine. We could change the sign to be division, multiplication, because ew. And then we could flip it. 10 over 1. So 17 times 10. That would work whenever we wanted to do. If we could do a keep, change, flip here, we could totally do that. 10 over 13. We can keep, change, flip here and get here. So there's lots of different pathways through. We are at the point in our mathematical careers where there is not one path from the beginning to the end. There are many, many different pathways through this forest of confusion, because I know that's where we feel like we live, is in the forest of confusion. There are many, many, many pathways through. You just got to find one. Okay? There's lots of different ways to solve these problems. We're going to work through several different options on how to do some solving and some estimating stuff as we continue through this chapter and figuring out where things go. G is definitely by far the hardest one on this page, and the hardest one we're going to do, especially dividing by decimals, especially if I tell you not to touch a calculator. Ew. It's the only time we're really going to do that. It's not going to be a thing we need to do on the regular, but knowing how these interact and with, like, occasionally multiplying by 10 is okay. We like that. It's all right. So the other thing we're going to do today is we're going to look at the next page. We're going to look at page 55. Totally different thought process. So page 55, I know it says page 80 up here. Page 80 is wrong. Page, I know, so many words. How dare I make us read a story? Ew. I know. I weep for you. Just say. All right, there we go. That's a better color. Not page 80. We are on page 55. Woo! So we've got a story about Felicia. And she's going for a drive. Bye, Felicia. Thank you. God, no one give it. I never get giggles out of it. Thank you. I'm just gonna say, y'all love all the puns I make. There's so many. All right, so we've got Felicia's going on the freeway to her cousin's house, and she notices she's real low on gas. Felicia's also kind of broke. Because she knows there's a gas station at the exit off the highway, but she's really hoping she's got enough gas to get there.
That's real.
It's real. I'm not saying it's not. I do it too, but that don't mean she's not broke. It's okay. We all live it. So she's gets on the highway. She knows she's got an hour and 15 minutes to get there, and that she sets her cruise control to 70 miles an hour. Cruise control is a good way to save on gas. And a lot more information. So we know she's going to go for an hour and 15 minutes. She gets 30 miles per gallon. And at the gas station that she goes to, it costs $3.50 for each gallon of gas.
That's expensive.
Anymore, it's expensive. There was a while that was a pretty good deal. But we're back to the point where that's expensive, and I'm okay with that. I remember being mad when it went over $2. I know, I'm old. It's okay.
2 years ago, a year ago.
When it was $2, I was in college. I remember when it went to $2 and it was like $1.99 and they had to switch it to a $2. I was mad. Costco's good. All right. So Felicia's driving and she wants to know if she's got enough gas and how much it's going to cost to get back home. So we got to figure out how far she's going so we can figure out if she's got enough gas. So what can we do? What do we know? What do we know? We know gas costs $3.50 per gallon. We don't really need it for this part of what we're talking about, but that is good information to know. I'd like a, we could know the gas prices reliably. Just switching it to be slightly more opaque. There we go. So we know gas costs $3.50 per gallon. What else do we know?
miles per gallon.
She gets 30 miles per gallon on her car. That sounds like something really important.
Drive an hour 15.
It takes her an hour and 15 minutes to get where she's going. One more piece.
70 miles per hour.
She's going 70 miles an hour. Those are the pieces of information we need. So I know she's going 75 or 70 miles an hour, and she's going for an hour and 15 minutes. And I know we get 30 miles per gallon. So we really want to find out how many miles she needs to go, right? How can I figure out how many miles she's going? Well, I know if she leaves home, ooh, home, it's so nice, and she drives for 1 hour, how far does she go?
What's the question?
If she drives for 1 hour, how far does she go? 70 miles. Because she's driving at 70 miles an hour, right? 1 hour and 70 miles. That's what 70 miles an hour mean, right? So, but she's not just driving exactly 1 hour. She's driving an hour and 15 minutes. So, that's great, but not super helpful. So I know she's going not a whole nother hour, but she's going 15 minutes. What part of an hour is 15 minutes? It is a fourth. If you think about 1 hour, if we think about half an hour, that's 30 minutes. And so if I think half of 30 minutes, that's our 15 minutes. So we have our 1/4 of an hour. So if we think about that 70 miles, is 70 miles something that we can divide into fourths in our heads easily? Because remember, Felicia's on highway. She's trying to think this while driving. Can we divide 70 into fourths while driving? Is there a number fairly nearby 70 that we could estimate to that's way easier to divide into fourths? Think of numbers around 70-ish. 80. So if we estimate if this is 80 miles, that's something we can divide into fourths easily. Because what's half of 80? 40. What's half of 40? 20. So in a quarter of that hour, she would go 20 miles. And yeah, that would be going a little bit farther than she needs to. Not super much farther, but a little. But better to have enough gas to get a little farther than you need to than a little bit not quite enough. Because if she can go 70 miles in this hour and 20 miles here, she's definitely got enough gas to get there. So we can round just to make things easier to think about. So if we think about this trip, instead of being 70 miles and 70 miles here, what is her total number of miles that she's going to go in her hour and 15 minutes? Ish, according to our estimate here. If she goes 70 miles in 1 hour and 20-ish miles, 90 miles. She's going to go 90-ish miles to get to her cousin's house. Or at the very least, that would get her far enough that she does not have to get out of the car and push. Because we don't want that. Maybe we're going to her cousin's house because it's a big party. Dressed up nice, in heels. I'm not pushing the dang car. If I got enough gas to get 90 miles, I can get there. So how many gallons of gas would she need? Because getting 90 miles is great, but I need to know how much gas that is. How many gallons of gas does she need to have for her trip? 3, because she's going 30 miles per gallon, right? If I can go 30 miles in a gallon, and I'm going 90 miles, 30 miles, 30 miles, 30 miles, that'll get me there. So if I have 3 gallons of gas, I can for sure get there. Yeah, that's a little bit more than she needs. It's a little bit more than we need, but not by much. Just a little bit. So if we get 3 gallons of gas, we can for sure get home. I would rather, again, I'd rather overshoot and be able to make it home and have a little left over than have to push the car home. Ew. I don't want to do that. Gross. Okay, so if she knows that she's got 3 gallons, she can for sure get there. This is all math that you can do while like in your head. You don't have to use a calculator with it. It is okay to estimate to get things close enough, especially if we go on the side of maybe a little extra. Maybe we have a little more gas than we need. Again, because I don't want to push it home. I'd rather have a little bit extra. So if she has to buy 3 gallons when she gets there, again, so she can get back home, how much would it cost for her to buy 3 gallons of gas from the gas station with her $3.50 per gallon? Again, $3.50 is not a super easy one to math with, right? No. What about that $3? If we bought $3 of gas for our 3 gallons, how much would that cost? If it was $3 per gallon? $9. So if we had $3 times our 3 gallons, what if we had 50 cents? Mm-hmm. Because 50 cents times 3 is going to give us $1.50, right? Those 2 pieces are easier to do individually sometimes. You could also do it as a 4 times the 3 gallons and take away $1.50. You do our 3 times the 3 gallons plus the $1.50. Either way, we're going to wind up with a total cost of about $10.50 to get our gas, to get back home. Or if we're giving our cousin gas for coming to get boxes out of her house, I'm giving you more money than it costs for gas. I'm not paying you to come get my stuff. So, estimating is great, but we're going to get it as close as possible because I'm not giving you extras. You're my cousin. I'm not paying you to come get stuff from my house. I'm not my cousins, but no, I'm not paying you for it. That would get expensive. I have a lot of cousins. I have 19 first cousins.
How many?
My dad has 7 siblings.
Oh, okay.
Yeah, I have a lot of cousins. It would be very expensive if I started overpaying my cousins for visiting. But keep it close, keep it accurate. Okay, so we're going to be doing a lot of estimating and kind of making these connections. A lot of this manipulation that we do in here is to really make sure that we can play with numbers like they're made of Play-Doh. In whatever way we want, we can squish them up and move them around however we choose for all kinds of reasons. Okay, we have, let's see, brain not braining, 7 minutes. I was like, I have a short activity, but honestly, it's not a huge deal. I'm just going to say, it's 2:17. We have 6 minutes. If you have not yet done the homework, please do. If you've done it, great. Have a great Tuesday.
Thanks.
You can't leave, but you can chill. Huh? The chapter, that's the what makes you happy. It's you sent your baby picture.
Oh,
That one.
I thought there was a different.
That I'll talk about it tomorrow. It's over what we're doing tomorrow. It's like I think of it like Facebook math when they put up like the emojis and that kind of stuff. Bless you.